All right, today we started with a quiz and people did reasonably well. There are a couple little things, especially about the way these things need to be written out in order to make everything very clear. When you're doing these, you want to write them in such a way that everything is expressed very clearly so that you'll retain it better. Okay, so we have the first expression. Numerator is the quantity x minus 4 times the quantity x plus 3 times the quantity x plus 5. There's a denominator. It's the quantity x minus 2 multiplied by the quantity x minus 4. This is called a rational expression. It's in the form P over Q, where P and Q are polynomials. So we'll write that R of x equals P of x over Q of x. P of x being the polynomial that you get, well, the numerator, which is a factored polynomial. We could always expand it and we get an x cubed term and an x squared term and so forth. And the Q of x, the denominator, is also a polynomial. It's a product of two binomials. Turns out it's actually a quadratic expression. But quadratic expressions are polynomials. Okay, so what do we do? Is there anything we can do to simplify this? We could expand it, but usually when we have something in factored form, we leave it in that form unless we have a reason to expand it. And right now, there's no compelling reason to expand it, and everybody's pretty good at expanding factored polynomials, so we're not emphasizing that. Okay, what do you do with this one? Well, first of all, let's write these factors in order. In the order, let's say, where x minus 4 comes before x plus 3, which comes before x plus 5, where the minus 4 is less than the 3, which is less than the 5. So it's in the order of the numbers that are added to x. A negative 4 is added when we get x minus 4, a plus 3, a plus 5, and those numbers are in order, increasing order. In the denominator, we have x minus 2 times x minus 4. Well, let's just write that as x minus 4 times x minus 2. This is not a necessary step, but it helps you keep things in order and help avoid confusion. So consider rearranging any factored polynomial in a logical way. Okay, now we see when this thing is in the new form that this is going to be the same as x minus 4 over x minus 4 multiplied by x plus 3 times x plus 5 over x minus 2. Because, of course, when we multiply fractions, we multiply the numerators and we multiply the denominators. That's still true when the fractions happen to have polynomials or any other kinds of factors, okay? So we always multiply numerators, multiply denominators, and you should understand that in terms of the way some simple fractions work. Okay, well then, x minus 4 over x minus 4 is just 1. We multiply that by x plus 3 times x plus 5 over x minus 2. And that just comes out x plus 3 times x plus 5 over x minus 2. There are no other common factors in these expressions. Between the numerator and the denominator, there are no common factors. So this is the simplest possible form of the factored polynomial. Now you can multiply the numerator out. You're going to get x squared plus 8x plus 15. You multiply the denominator out. Well, it is just x minus 2. And that would be okay. That would be fine. The one thing I discourage is just crossing out the x minus 4 here and here, because you're not being very careful about making sure there's a tendency for people not to be very careful about making sure that what they cross out is a factor of the denominator and also a factor of the numerator. There are other common errors that come out from crossing things out. Some people want to cross out the -4 and the -4. -4 is not a factor of the denominator. -4 is not something you could factor out of the denominator, okay? Can't do that. Okay, got to be factored. Now, let's look at this one, which is fairly straightforward. We have x minus 3 times x plus 7 over x plus 2 added to x plus 5 times x minus 4 over x plus 2. The denominator is the same. So we could actually factor the denominator out of these two terms, but just if you have the same denominator, you know that it's okay to add the numerators. So this becomes x minus 3 times x plus 7 added to x plus 5 times x minus 4. All that divided by x plus 2. Now, we don't multiply the x plus 2 by the x plus 2. If this was 3/8 plus 1/8, you'd have eighths. You'd have 3 of them here, you'd have 1 of them here, which would make 4 of them. You'd have 4/8. Let's write that out. 3/8 plus 1/8 is 4/8. If you cut a piece of pie into 8 pieces and somebody has 3, somebody else has 1, they have a total of 4/8, which is, of course, 1/2. In this case, this would reduce. This probably doesn't, but just to make sure, I'm going to go ahead and multiply everything out. X minus 3 multiplied by x plus 7, and you need to do this in detail. It's x squared minus 4x minus 21. And x plus 5 times x minus 4 is x squared plus x minus 20. So all I've done here is I've multiplied the first two binomials to get x squared minus 4x minus 21. And I made a mistake. It's x squared plus 4x minus 21. And x minus 5 times x minus 4 to get x squared plus x minus 20. Well, that equals, we got x squared twice, we got 2x squared. 4x and x makes 5x. Negative 21 and negative 20 is negative 41. That's over x plus 2. 41 is a prime number, and if you play around with it a little bit, you'll find that this numerator doesn't factor a bit, okay? At least not over real numbers. Now, you can use the quadratic formula and get a fairly complicated expression and express this as a product of two factors, but we're not going to worry about that. Okay. Another thing you can see is that negative 2 does not make this numerator 0. Now, if x plus 2 is a root, then negative 2 has to, plugged in, has to give you 0. Okay? So if x plus 2 divides this numerator, then plugging negative 2 into the numerator would give you 0. And plugging 2 into the numerator, what do you get? 8 plus 10 is 18, minus 41 is negative 23. It's not 0. So among other things, this does not reduce. Okay, let's try another one. We have x plus 4 over x minus 3 added to 2x minus 5 over x plus 4. The denominators are different. We can only add fractions or rational expressions if they have the same denominator. Well, just using the familiar trick from adding fractions, and if you're not up to date on adding fractions, you need to get up to date. I'll just do one quick little, and let's say we got 4/7 plus 2/3. In order to add that, we need a common denominator. Well, we can always multiply denominators to get a common denominator. Usually we want the least common denominator, but since 7 and 3 are relatively prime, well, 21 is going to be it. So I'll just say common denominator is 21. Just make a note of that. Okay, my denominator of 4/7 is 7, but I can get an equivalent fraction by multiplying 4/7 by 3/3, because 3/3 is just another way of writing 1. 4/7 times 3/3 is just another way of writing 4/7. Then we have 2/3, and we multiply that by 7/7. That would give us 12/21 plus 14/21. And now we have the same denominator. We can add the numerators. 12 and 14 gives us 26/21. Now, 21 only has factors 3 and 1, 3, 7, and 21, but non-trivial factors 3 and 7, and neither of those goes into 26. So that's in lowest terms. Okay, just to review what we do when we add fractions. We're going to do something very similar here. We're going to say the common denominator is x minus 3 times x plus 4. So we have to rewrite both of these fractions with denominator x minus 3 times x plus 4. Well, take the first expression, x plus 4 over x minus 3. We want to get the denominator x plus 4 times x plus 3. And we've got the x plus 3, so we need a denominator x plus 4. But we can't just write a fraction symbol with an x plus 4 under it without writing something over the top. And if we want the fraction to continue to have the same value, whatever we're multiplying by had better be 1. So we multiply by x plus 4 over x plus 4, just analogous to the way we multiplied 4/7 by 3/3. We get our common denominator. Before it was 7 times 3 is 21. Here the denominator is x minus 3 times x plus 4. That could be multiplied out, but until you've got everything simplified, you want to keep it in factor form. Okay, then we've got our 2x minus 5 over x plus 4. And we multiply that by x minus 3 over x minus 3. And now the denominator matches. So our two denominators are identical. Now one is x minus 3 times x plus 4. The other is x plus 4 times x minus 3, but they're the same. Doesn't matter in which way two things are multiplied, you're going to get the same result. Okay, so what we then get is x plus 4 multiplied by x plus 4 plus 2x minus 5 multiplied by x minus 3 divided by x minus 3 times x plus 4. And what does that equal? Well, if we multiply x plus 4 by itself, it gives me x squared plus 8x plus 16. And 2x minus 5 times x minus 3 gives me 2x squared. Let's see, 2x times negative 3 is negative 6x, and negative 5x, negative 11x, and negative 5 times negative 3 is plus 15. All that's divided by x minus 3 times x plus 4. Now I'm going to erase this little thing I did with the fraction down here, because I need the board space. We then want to combine the two expressions in the numerator, adding like terms, adding the squares to the squares and the first powers to the first powers and so forth. And what do we get? X squared and 2x squared is 3x squared. 8x and minus 11x is minus 3x. 16 and 15 gives us plus 31. X divided by x minus 3 times x plus 4. Now, having a prime number like 31 here makes it very likely that this is going to factor. I would check if x minus 3 is a factor of the numerator, then plugging 3 into the numerator would give us 0. If we plug 3 into the numerator, 3x squared gives us 9, minus 3x gives us 9, that's minus 18, plus 31 is 13. So when x is equal to 3, the numerator is not equal to 0, so that x minus 3 is not a factor of the numerator. If x plus 4 is a factor of the numerator, then x equals negative 4 will be a 0, will give us 0. So if x is negative 4, 3x squared is, well, x squared is 16, 3 times that is 48. And then minus 3x is minus 12. Well, that gives us 36. And then we add 31, we get 67. X plus 4 is not a factor of the numerator. So this is in lowest terms. Now there's another way we could have told, if you're interested, that the numerator is not going to give us the 0. We can check the discriminant, the b squared minus 4ac that we take the square root of in the quadratic formula. If we set this equal to 0, the discriminant is going to be b squared, well, b is negative 3, so that's 9, minus 4 times a times c. A is 3, c is 31, a times c is 93, and 4 times that is 372, I think. So, and that's negative. Okay, so we're subtracting that from the 9 that we get when we square the negative 3. In other words, discriminant is greater than 0. I'll just write down here. B squared minus 4ac is negative. And before anybody gets confused, I'll write in the numerator is negative, which also tells us that this is in lowest terms. The numerator is in lowest terms. We could then, if we wished, multiply out the denominator. I usually don't ask people to do that. In case open math does, we'll demonstrate 3x squared minus 3x plus 31. Just demonstrate what we mean. X minus 3 times x plus 4 is x squared plus x minus 12. So open math might want that form at some point. Now here's a slightly more complicated example. X plus 5 multiplied by x squared plus 25x plus 10 divided by quantity x plus 5 squared times x minus 3 quantity squared. We want everything to be factored. So x plus 5 is factored, x minus 5 squared, x minus 3 squared. Those are all in completely factored form. There's nothing you can factor out of any of those three. But how can we factor x squared plus 25x plus 10? Well, one of the first things we like to check is special products. If you don't remember special product, you really need to go back and review it. So there's a special product that applies here. So go ahead and factor that and work this out if you're watching, if you want to really understand it, because you don't understand anything very well just by sitting and watching it. Okay? And I'm going to get to it in just a minute. Okay, hopefully everybody has attempted to progress in this problem. My suggestion was to factor this term, and you find that you have x plus 5 in your special product, or a plus b squared is a squared plus 2ab plus b squared. And you probably didn't have any success factoring this because it doesn't factor the way I said. We got the 25 and the 10 backwards. So let me just say that, ignore what I just said, that doesn't factor. You could try setting x squared plus 25x plus 10 equal to 0. But you're not going to find two factors, integer factors of 10, or even rational factors of 10 that are going to add up to 25. Okay. You could use the quadratic formula. You could check the square root of b squared minus 4ac. You're going to get 625 when you square b. 4ac is going to be 40. So you subtract that from 600, you get the square root of 585. So I just make a note. I believe that equals 585. Square. 625 is 670, 576 is. That's between 576, which is the square root of, which is the square of 24, and 625, which is the square of 25. So you're not going to find a square root there. So we're just going to write this as x squared plus 25x plus 10, and we make a note. This thing has no simple factors. That over x plus 5 squared times x minus 3 squared. Now we've got an x plus 5 squared times in the denominator and an x plus 5 in the numerator. A lot of people just cross out the x plus 5 squared, cross out the x plus 5. Don't recommend it. First of all, I'm going to write this as x plus 5 times x squared plus 25x plus 10. There's our numerator. And the x plus 5 squared, I'm going to write as x plus 5 multiplied by x plus 5, because that's what it means to have x plus 5 squared, times x minus 3 quantity squared. Now I could write this as x plus 5, or x plus 5, multiplied by x squared plus 25x plus 10, divided by, well, there's the other x plus 5. We got to have it. So our denominator, well, again, we have x plus 5 over x plus 5 multiplied by x squared plus 25x plus 10 over the other x plus 5 multiplied by x minus 3 quantity squared. X plus 5 over x plus 5 is 1. So you just end up with x squared plus 25x plus 10 over x plus 5 times x minus 3 squared. Then if you're in a situation where you're expected to expand the denominator, you're safe expanding it. You can double check if x plus 5 was a factor of x squared plus 25x plus 10, then negative 5 would be a 0 of this x squared plus 25x plus 10. Well, if you square 5, you get 25. 25x is 125, and 10, your numerator is 150. I'm sorry, if x is negative 5, x squared is 25. 25x is negative 125. So that gives you 25, negative 125 is 100, plus 10 is 110. Okay, sorry, negative 110. Okay, x squared would be 25. 25x would be negative 125. 25 negative 125 give you negative 100. Add 10, you get negative 90. You clearly don't get 0, and that's really the bottom line. And if you plug in then x equals 3, you'll verify that x minus 3 isn't a factor of the numerator either. You're going to get x squared would be 9, 25x would be 75, that'd be 84, and 10 is 94. So, okay, so we can now say now if I write the expression I intended to write up here, but I'll do it with slightly different numbers. I'll do x squared, x plus 6, multiplied by x squared plus 12x plus 36 over x plus 6 squared times x minus 4 squared. See if you can factor this and rearrange it so that you eliminate all common factors and end up with an expression that has no common factors. Okay, now the class has taken some time with this and pretty much got it well. There's a few little glitches. If you're watching the video, stop, do what I ask to the best of your knowledge, best of your ability. Okay, so we can say now, okay, we got x plus 6. That doesn't need any factoring. X squared plus 12x plus 36 is the square of x plus 6. Okay, again, we use a special product. And the denominator is x plus 6 squared times x minus 4 squared. Well, you have an x plus 6 squared in the denominator and an x plus 6 squared in the numerator. Without rearranging the order of everything, it should be very clear. If I multiply x plus, well, if I write x plus 6 squared times x plus 6 squared, factoring out the x plus 6 squared from the numerator and denominator, from the numerator, I'm going to still have an x plus 6 left. The denominator, I'm just going to have my x minus 4 squared. And since x plus 6 squared over x plus 6 squared is 1, the result is just x plus 6 times the quantity x minus 4 squared. And you don't have to do any more with that one, unless somebody wants you to square the x minus 4. I'll just go ahead and do that. That's real easy. X plus 6. You just use a special product, or you can use a distributive law. You ought to understand how the special product represents a special case of the distributive law. Yeah, I say this step is optional in my class, unless it's required or somehow useful to do the complete expansion, or to keep things in factored form. They're simpler. It's more obvious what the structure of the expression is. Okay, well, about time. Yeah, just time. One more example. Okay, I'm losing it here. Okay, now factor these, see if anything divides out. Okay, hopefully you've done that. People in the class are pretty well successful in factoring these. X squared minus 3x minus 10 factors as x minus 5 times x plus 2. Because x times x gives you the x squared, minus 5x plus 2x gives you minus 3x. Negative 5 times 2 gives you negative 10. X squared plus 5x plus 6, you can easily verify, is x plus 2 times x plus 3. In the denominator, x squared plus 4x minus 12, I believe factors as x plus 6 times x minus 2. Okay, so let's see if we're right here. X times x is x squared, 6x and negative 2x is 4x, and 6 times negative 2 is negative 12. X squared minus 4x plus 3 is x minus 1 times x minus 3. Well, now that everything is find that there are no common terms. Just to be sure, let's do everything in terms, in order of these numbers that are added to x. In the numerator, doesn't change, negative 5, 2, 2, 3. In the denominator, let's start with the x minus 3, then the x minus 2, then the x minus 1, then the x plus 6. And there's no x minus 3 in the numerator. There's an x plus 3. Easy to confuse that. And there's an x minus 2 in the denominator. We have x plus 2s in the numerator, a couple of them. So we don't want to do that. And there's no x minus 1 or x plus 6 in the numerator. So this is completely factored. However, we do want to write out the result in more compact form by expressing x plus 2 times x plus 2 is quantity x plus 2 squared. And then, I wrote a bad 3 up here. It looked like a 5. So write things more neatly than I do. Okay, so there we have numerator x minus 5 times x plus 2 squared times x plus 3. Denominator x minus 3 times x minus 2 times x minus 1 times x plus 6. Now, in case I didn't read everything out when I started, the original expression had numerator quantity x squared minus 3x minus 10 multiplied by the quantity x squared plus 5x plus 6. The denominator had the factor x squared plus 4x minus 12 multiplied by the factor x squared minus 4x plus 3. We factored x squared minus 3x minus 10 in the numerator and got x minus 5 times x plus 2. Factored x squared plus 5x plus 6 in the numerator, got x plus 2 times x plus 3. Factored x squared plus 4x minus 12 in the denominator, got x plus 6 times x minus 2. Factored x squared minus 4x plus 3 in the denominator, got x minus 1 times x minus 3. Leading us ultimately, leading us then to the expression with numerator quantity x minus 5 times the quantity x plus 2 times the quantity x plus 2 times the quantity x plus 3. In the denominator, the quantity x minus 3 times the quantity x minus 2 times the quantity x minus 1 times the quantity x plus 6. Checking through, we find that there are no common factors between the numerator and the denominator. So now we just write the same expression we just had, except the x plus 2 times x plus 2 will be replaced by x plus 2 quantity squared. Okay, so we've seen how to factor and, if possible, simplify rational expressions, and we've seen how we add them. Now, multiplication and division are very straightforward. People have very little trouble with that if they do it honestly, okay? And if anybody does have trouble with it, we'll certainly address it when we learn that that is an issue. Okay, so good luck on the homework, and I'll see you next time.